Okay, guys, so welcome back. So we will continue our discussion on Linux. So what we discussed in the previous session is that we discussed about the operating system, right? Like why we need an operating system, and operating system is it's an interface between your application and the hardware. That's what we discussed it, right? And whenever you are running any application or whenever you're running any program, you can actually run or execute any program with the help of an operating system itself. Without operating system, you cannot run any program or the application, right? So operating system has to be there, and operating system, it provides an interface between user and the hardware. And we also learned, or we also understood, like what are the different components of your operating system. There are 5 different components, right? So starting from your file system, process management, memory management, file management, device management, and network management. Okay, so we understood about each and every different management, like just one line information about each and every management. But this itself altogether, right, it's a very big ocean. If you want to get into each and every model, right, it will take a lot of time to understand and learn. So that is completely out of scope. So we will not be learning all those things. Those are all system level programmers who does it actually, or the embedded engineers who works on those areas, right? They will be knowing all these components very well. Now, so what we're going to understand now. So now, as I said earlier, like when the operating system came into existence, right, the Unix operating system, it came into the existence in 1975. Okay, by AT&T Labs. So this is the company where, this was a very big organization. Even today also we have AT&T company. It's a very big telecom based company, but AT&T also has had its own lab actually. And also there were many other organizations which were involved in doing a lot of like innovative activities. Like we have Bell Labs, we had Manchester Institute of Technology, MIT University, BSD, Berkeley Software Distribution. Many kind of organizations were there during that time where they were working on the development of the operating system. But AT&T is the one who came up with this Unix operating system, right? And this Unix operating system, the design of the Unix operating system was laid down by Ken Thompson. He is a guy who actually designed the complete Linux operating system actually. But along with the Ken Thompson, there were many other people who also were there who were involved in developing this Unix. And one, Joseph Osana. And you have heard about this person by name Dennis Ritchie, right? You have heard his name. So Dennis Ritchie is a father of our C language, right? The C language was designed by Dennis Ritchie. So Ken Thompson is the actual brain behind developing this Unix operating system. But many other people joined with him, and they came with this Unix operating system. The whole Unix operating system was earlier written in the assembly level language. It was written in assembly level language. Assembly level language are machine language. We say machine language. So where you have come across some binaries, right? Where you have a binaries like 1 zeros, right? Binaries, right? So those binaries are, but the machines understands only the binary language, zeros and ones actually. Oh God, some background noise is going on. Okay. So guys, are you able to hear it? Are you facing?
No,
Are
no,
you
we
hearing
are
any
not able
disturbance?
to hear
No,
any
no issues.
background noise.
Hearing it, a lot of sound is coming. That's fine. Okay, so machine language are nothing but zeros and ones. So those are binary languages where the machines understands it actually. So initially, the Unix operating system was designed or was developed in the assembly level language or machine understandable language. But it was very complex, and the modularity was not good, the portability was not in a good way, and even maintainability was very difficult. There are a lot of disadvantages were there when they designed the Unix operating system, and they had written the whole Unix operating system in assembly level language. That's the reason what happened, right? During that time when Ken Thompson designed this Unix operating system, he's the same guy who had even come up with the B language actually. B language. He has designed his own language. He calls it B language, but B language had its own limitations. So that's the reason Dennis Ritchie worked with the B language and tried to find out what are limitations were there, and he designed a new language which he called as a C language. And now Dennis Ritchie thought that let me rewrite the whole code of the Unix operating system, which was written in assembly language. Let me write into a C language actually. So what Dennis did is a great guy. He did what he did, right? He rewrote the complete. He rewrote the complete Unix operating system from assembly level to C language. This is the major breakthrough which came into that time, because that people were understanding the C language. Now they can understand the whole code of the operating system by going through the C language. By going through a program, if you know, right, if you open any program, right, you can able to understand what are the functions which are being defined, what are the variables it has been defined, right? You can go to the whole function and what are the functions APIs are used in your program. So if you have a basic knowledge, you will be able to understand what that program does. Similarly, when the people started looking into the code of the operating system by reading the C language, they were able to understand the whole logic behind, like how this Unix operating system was designed. And what are the different components of the operating system? Like you have file management, memory management, device management, network management. They were going to the complete code and they were understanding the whole aspect of how exactly this operating system was working. So this, when it came to it, all these things, this nearly it happened in 1976 or 78, if I'm not wrong. At that time, a very robust and a production-based operating system was released into the market. And what this AT&T did, like they released it and they gave this Unix operating system to freely for all universities, for a lot of other forums, for a lot of scientists. They gave this. A lot of big giant companies were there at that time. Like for example, the companies like Xerox, IBM, HP company, Sun Microsystem company, BSD, Berkeley Software Distribution, MIT. There were a lot of corporate organization, universities, a lot of people. They started circulating this operating system, and they gave a big manuals. They gave a lot of floppy disks and all, where they had created an image of this operating system, and they gave them. They said that please go purchase a PDP-11 machine. At that time, they had a PDP-11 machine. Go and install it, and you will be able to boot the operating system, and you can able to communicate with the operating system or communicate with the machine. That's how they started doing it. But one big mistake what AT&T Lab did at that time is that they started giving even the source code of this whole operating system, Unix operating system, to all these companies just for some $15. Just for $15. $15. They gave. Who gave? The AT&T company, the AT&T Lab, the AT&T Lab. They gave just for $15. AT&T Lab gave the source code. Means the entire source code of the Unix operating system itself, they started giving to other companies, to other forums. So what this giant company, they did know, IBM, HP companies, and they took the code just for $15. They looked into the whole code of the operating system. They understood what the operating system does, how it works internally, and they came up with their own Unix flavors actually. So IBM company, they came with their own IBM AX operating system. Similarly, HP company, they came with the HP UX operating system. And one more is a True 64, which is not existing now, but there are many operating systems which HP came at the time. Similarly, what happened? The Sun Microsystem company, they came up with the operating system, the Solaris operating system. BSD, they came with the Berkeley Software Distribution. BSD 1, BSD 2, BSD 3, like that. These are the operating system which came into the market. So during that time in 1980s, right, you could see that a lot of different flavors of Unix operating systems where they came into existence. Yes, Sun Solaris company. Yes, Sun Solaris. So Sun Microsystem company. Now this company, it no more exists, because this company was acquired by the Oracle company, and Oracle company took over the control of the Solaris operating system, right? And Sun Microsystem was one of the co-founder of the Sun Microsystem companies. What is his name? I have forgotten. Jim. Something. Jim, I have forgotten his name. I will recall and tell you. He's one of the co-founder, and he's the same person who even designed the VM. Like Vim editor. What are the Vim editor is there, right? Vim editor. He only designed it actually. Bill Joy actually, not Jim, not Jim. Bill Joy. So Bill Joy is one of the co-founder of Sun Microsystem, and he's the same guy who designed this VM editor. And Sun Microsystem is a company who came up with the Java. The Java was designed by the Sun Microsystem company itself. And the Sun Microsystem is the one who came up with the Solaris operating system. Solaris is also one of the flavor of Unix operating system. And this was in a huge market. I mean, even today also some companies are using Solaris, or else they are migrating from Solaris. For example, a company like EMC, Dell EMC, still they're using Solaris. Many of the applications still they are running in the Solaris operating system. In my previous organization where I worked, right, Lumen Technology, still we are having many servers where those applications, many of the critical applications are running in Solaris boxes. But Solaris, HPUX, IBMX, all these are obsolete, guys. It means that there is no more support, no more development is going on. I started my career at HP company. I was working on this 264 and HPUX operating system. In 2009 itself, they stopped the supporting HPUX operating. 2011 itself, they stopped supporting HPUX operating system. It means that no more new features, no more new releases of HPUX. So it was an end of the HPUX, because most of these companies, IBM, HP, Sun Microsystem, Oracle, they shifted it to Linux operating system. So these were very early flavors of Unix which came into it, and most of the people, they started using this operating system. To be very frank and specific, these were all very good operating system, guys. HPUX, IBMX. I got an opportunity even to work on HPUX, IBMX, even on Solaris also. So these are all very, very robust operating system. But what happened, right? People were looking for some kind of an open source operating system which was freely available, because purchasing IBM AX and all, right, it is a huge cost. You need to even buy the IBM AX server, okay, which is having a IS64 processor. Similarly, you have to buy a HP UX Superdome servers so that you can install HPUX. HPUX operating system, you cannot install in a very simple x86 processor. No, you cannot install it. It will not get supported. It only supported in that particular IS64 processor, and that too in the Superdome. Superdome servers are HPUX servers, actually. If you go to the Google, I'm just telling you, and if you say HPUX Superdome server, see, HPUX Superdome server images. See, guys, this is a HPUX Superdome servers, actually. See, yeah, this is the HPUX. See, HPE Superdome servers, actually. This is HPUX Superdome servers, actually. So it uses this Iris processor and all, PA Iris processor and all, Intel also. Here only, we even sometimes we call it the blade servers also. We call this as a blade server. So you were able to only install the HPX operating system only on those servers. You cannot install any other processor architecture. You cannot install it. It is not possible. But what happened, the time came up where most of the customers, they cannot pay so much huge cost for licensing cost for HPX operating system. And again, on top of that, you need to even purchase the Superdome servers, which was huge costly. And really, no customers were not willing to spend that much. That's the reason what happened. The trend started where people started going into the very low configuration servers, like a simple x86 servers or a simple blade servers they were going. And they used to happily install Linux on top of it and started working on that, because whatever their requirement was, everything was getting sufficed by Linux. Then why I need to pay so much licensing cost for all these servers and all this operating system licensing cost? It is not at all required. That's how you could see that this trend started from 1996, 97, right? 1996, 97. The trend started where people started shifting into the Linux, and the market for this other flavors of Unix like IBM AX or HPX or Solaris were getting down day by day. It was getting down, and by 2004 or 2005, as per my knowledge, when I discussed with a lot of my seniors, they used to tell that by 2004, 2005, like Linux was ruling this whole world, actually. Like I'm talking like 20 years back, I'm saying 20 years back, the Linux was ruling the world. A lot of companies, they started shifting into the Linux, actually. So now when this Unix was designed, many other flavors Unix came into the existence. Like companies were using all these flavors of Unix to design and develop an application to run it and everything. They're making a lot of huge money also from this. A lot of critical applications still works on many of these HPX or IBM server, but they have now migrated into the Linux. Linux supports most of the critical applications. For example, like if you go to the Bombay Stock Exchange or if you go to the New York Stock Exchange, like thousands of gallons of data are displayed in it. So many computing happens, right? So many data computing happened, so many data is getting shared. In the in the back end, lot of lot of Linux servers are running actually, and all those high computing servers, you will find everything on Linux itself now. So if you go to the Bombay Stock Exchange, you'll have hundreds of servers over there who are maintaining the whole Bombay Stock Exchange. Similarly, New York Stock Exchange. Similarly, like you are doing a lot of big in-transit transaction through net banking transactions, right? You could see that all these things happening, everything in the backend in the Linux server itself, actually. So all kind of a high computing processor things, whatever you need it, right? You can easily achieve even through Linux operating system. That's what many people, they shifted from this traditional Unix variants of operating system to the Linux. They started moving it. They started migrating it actually, because it's an open source Linux. You need not to pay any licensing cost. It is freely available. You can install it and you can make it run. Clear? So now, fine. Now, this was all happening. It's good. Many other companies were making a lot of money out of it. They were making a lot of money out of it. 1 second, please. Okay, sorry, I got a call. So a lot of companies like HP, IBM, they were all making a lot of money from this, because those all were proprietary operating system. Now, in the same time, what happened, right? During 1987 or 87, there's a guy by name Richard Stallman. He was basically a student at MIT. So he saw that a lot of big giant companies, right? They were making a lot of money out of it, and they were making this operating system, everything as a proprietary operating system. It means that you need to pay with the licensing cost, and we will not show you any kind of a source code of this operating system. So what he did actually, Richard Stallman, at that time, he was a student at MIT, and as a project, he has designed a compiler, and he called it as a GCC compiler. This whole GCC compiler was designed by Richard Stallman actually. Now, this Richard Stallman, what he did, he quit from the MIT. He left the MIT organization. He had already designed this GCC compiler and many other tools he had designed, and he started his own organization. It is called as a Free Software Foundation. He started his organization called the Free Software Foundation. So what he says that if anyone is willing, suppose tomorrow you have designed your own application, or you have come up with your own anything, any application or any system level code, also system level application also, if you have designed and come, and if you are willing, you can give your code under the Free Software Foundation such that it is easily available for anyone. Anyone can go to the code, they can understand the code, they can try to even modify the code. So you can do under the Free Software Foundation licensing, you can take up the code and do it. So what Richard Stallman did that, he took this GCC compile, the whole code, he had kept under the Free Software Foundation. There is a website also, I think fsf.org.
Not represent real life. Please play in moderation. Take frequent breaks and play responsibly.
Okay, guys, please mute. I would request everyone to mute it. Girish sir, I think Anirudh and Girish PM, could you please mute yourself? If you have any doubts, then only ask me. And also, yeah, I think only 2 people are. Yeah, sure. Thank you. Lawrence also, anyone who has unmuted, right? Mute, or else I'll mute it. Okay. Sure. Thank you. Thank you. Yeah. Okay. So there's a site also, FSF organization, fs.org, or Free Software Foundation. Under the Free Software Foundation, what Richard Stallman did, he put all the entire code. Okay, entire code, and that is available to anyone. So anyone who can put the code under the Free Software Foundation, like GCC compiler was the one, they can completely download this compiler code and they can go through it. They can understand the whole architecture of this compiler, and they can even modify it if they need it, and again put back the same modified back to the Free Software Foundation, such that it is going to increase the creativity, right? So that's what. So he's the same guy, Richard Stallman, who coined the term by name open source. You might have heard, right? Open source. Okay, Linux is an open source. Jenkins is an open source, right? Terraform is an open source. You might have heard this terminology a lot, right? This term open source was actually coined by this person by name Richard Stallman. He's a fellow actually. Okay. So a lot of at that time in 1987 and 88, a lot of people, they became a part of this Free Software Foundation. A lot of developers, hackers, and great people, they became a part of it, and they started contributing to his community actually. So a lot of people who had designed some kind of a tool like Yak tool or Lex tool or compiler, libraries. So many things were there which were contributed to this foundation. So it became an open source, and people started understanding this whole stuff by going to the code actually. Okay, so hit term. So a lot of people also at that time, like the Bill Gates, who is a founder of Microsoft company, he was very much against with the Richard Stallman theory. What Richard Stallman say that if you are willing, if you are okay, you can give your entire code to the Free Software Foundation so that it is easily available for anyone. Anybody can download the code, anybody can go to the code, anybody can modify the code and put back the same modified code back to the Free Software Foundation so that it is going to increase the creativity, right? This is what Richard Stallman says. But Microsoft, Bill Gates, he was very much against with his theory, Why? Because what Bill Gates say that why we need to give so much our hard work to code everything as a free to everyone. We are against with this theory, and we don't follow this one because you cannot make many money out of this. That is what the Bill Gates was very much against. But Richard Stallman was firm with his belief, with his foundation, and he said that no, you can make. If you don't allow this as an open source, right, you cannot increase the creativity. Right, a lot of people will not know how this software works, happens and all, right? But by making this, Richard Stallman, he has opened a door to many people, many hackers and many developers who were there in the world, right? He allowed them to explore many things actually, because by going to an open source code, right, you will get a lot of ideas, and you can even enhance the existing code, or you can even come up with your own application or the product. There are a lot of things are there which you can explore and come up. So once you allow this to happen, then only the creativity will get increased. But Bill Gates was very much against, and you will find a lot of articles in the net where there's a huge conversion goes between these two people, Richard Stallman versus your Bill Gates. So you can go to that article, you can just type Richard Stallman versus Bill Gates in your Google. You will find hundreds of mails and exchange between these two people where they're sharing about their thought process. So Bill Gates was very against, and he said that we will not be able to make the money. But as you know, guys, in today's world, most of the softwares are open source, and you know that we are making money out of it as part of paying support job, right? As part of supporting that tool, right? Even though it's an open source, companies are using. But what happened? The companies might need some kind of a support from the tool. Hence, what happened? There is a supporting charges there. You need to give the supporting so that it goes. You can able to make a money. So in today's world, most of the money is generated to the open source tools and softwares only. Clear? So this open source word was coined by Richard Stallman. This is all happened in 1987, 88. Fine, that's all fine. Now, in the year 1991, so guys, I'm making it very short. I'm not going into much detail. In 1991, a person by name Linus Benedict Torvalds, Linus Benedict, or just directly say Linus Torvalds, somebody said Torvalds, somebody said Torvalds. Okay, Linus Benedict Torvalds. He was a student at. He was a student. He was from Finland. He was studying. He was studying his engineering, and basically he was into his final year of his engineering. Okay, and he was a student at Helsinki University, which is there in Finland. So he was a student, and he was very much passionate at the very engaged on on doing coding and all, right? Like how Bill Gates or even like Steve Jobs, they were at the very earliest when they started coding. Similarly, Linus Torvalds at the very young age, he started coding actually. He started writing a lot of codes actually. So when he got into his graduation and when he was into final year of engineering, as a part of the final year of engineering, he was supposed to come up with a project. Actually, he was supposed to come with a project, and as a part of the project, he started working on developing an application. He came up with he was developing an application actually, and that application he was actually making that application to work under the Unix operating system. There was one operating system by name Unix. It was actually designed by the person by name Andrew Tenenbaum. Unix operating system, as the name says, Unix means very small, miniature operating system, very small operating system. So this fellow, Linus Torvalds, he written an application. Guys, I'm getting a call, guys. Just a minute. Guys, just a minute. Sorry, I got a courier. I have to go down to collect the courier. I'll be back. Just a minute. Okay, guys. So when Linus Torvalds, when he had developed an application, when he was making it to run under the Unix operating system, which was designed by the Andy Tenenbaum. So Andy Tenenbaum, by profession, he was a professor, and he has designed this Unix operating system. And he never made it this Unix operating system code available to anyone, because as he was a professor, to show to his students what is an operating system is all about, how to work with an operating system, he has designed this Unix operating system, and he was giving for practicing the students. So he gave this Unix operating system to them, and he told them to ask them to work on this operating system, right? So Andy Tenenbaum. So what this fellow Linus Torvalds did, right? He wrote an application and he was working on that. He found a lot of limitations, and later he tried to debug, and he tried to come up with a conclusion that there is some issue with this system, with this operating system itself. So he thought that if this code is given to me, if the Unix operating system code is given to me, I can able to debug that issue and fix the issue. So hence what happened, Linus Torvalds, he personally connected with Andy Tenenbaum by sending an email to him, asking him to share the code if it is possible. Since Andy Tenenbaum hesitant, he was not agreeing to give the code to the Linus Torvalds. He said, no, I will not be sharing my code. Why I need to share my code? It is my code which I have written. So he never shared the code of the Unix operating system to Linus Torvalds. Then the challenge came to the Linus Torvalds that, okay, now how I can make my application run? That is not possible, right? Because you don't have an operating system which supports his application, or whatever the code he has written, right? That the application will not be able to execute in this Unix operating system. So hence what happened, Linus Torvalds thought that let me write my own operating system from the scratch itself. Oh, right. So what he did, right? He took the idea from the Unix operating system. He took the idea. Linus Torvalds took the idea of the Unix operating system. He started designing. He started writing a code of the operating system within a span of like 10 months. In a span of 10 months, he designed the complete operating system, which he called it as a freaks. Why he want to keep the name as a freaks? Because freaks means, why he want to keep the name as freaks? Because Linus Torvalds, Benny Torvalds was very much impressed with the Rajesh-Devops theory and with his foundation. what his theory says, oh, everything is free available, anybody can download the code, anybody can put the code into the free software foundation. Like that, he was very much impressed with his theory. And also what he thought that whatever I design today, I'm going to put everything under the free software foundation, and I'm going to make the whole code what I've written under the open source, so that anybody can walk through or go through my code. Right? So anybody can walk through or go through my code. That's the reason what happened, right? He kept the name as a Freaks. It's a Freaks operating system. And also he took some ideas even from IRIX operating system, IRIX and IBM operating system. He took some ideas from them because he started working on these different flavors of Unix operating system at that time. And finally, he kept the name as a Freaks. But our Linus Torvalds friends, followers, or his well-wishers, right? They hesitant or they didn't agree to keep the name as Freaks. Instead, they want to keep the name as instead they want to keep the name as Linux. Why? Because that this whatever he has designed, right? That is a clone, or it is like a ditto, like a Unix operating system with many more features, right? So that's the reason what happened, right? The name instead of S, it was replaced with the X actually. Then finally, guys, the Linux operating system came into existence in 1991. And the whole operating system, the entire operating system of Linux operating system was written by Linus Torvalds. We call him as a Linus Torvalds. He's a father of Linux actually. Okay. And so in 1991 it was released, and what Linus Torvalds did, that Linus Torvalds, he started his own website. He called it as a kernel.org. And what he did, right, he tried to keep the whole Linux source code, everything, right, into this. And the first version which he released was 1.0 kernel version. 1.0 kernel version was released actually. Kernel version which was released. The whole source code was everything. And it was open source. Anyone can go and download the code, operating system and everything. They can go through the code, they can understand the code, how operating system works. So a lot of people, they started downloading, going through it and all. Right? So that is what it is started actually. That's how he started this Linux actually. Okay, now what happened, right? When he started this kernel.org organization, okay, a lot of other people also joins hands with them. Like for example, Robert Love, Craig Crotch, Hatzman, many great people were there who joined along with him, and they also become a part of this kernel.org. Even today also, Linus Torvalds is there. Like he is there. I think he's 52, 54 age. He's still working on it. And you know about the Git tool. You might have heard about the Git tool, right? Git is the source code versioning tool. The Git was also designed by Linus Torvalds himself, actually. He's the same guy who designed even the Git also. Now, so 1.0, 2.0, 3.0, 4.0, 5.0, you have a lot of kernel versions are there. All kernel versions you'll find in kernel.org. If you go to the site here, you guys, you'll find all the kernel. So now, right now, the latest kernel version is 6.5.2. You can download the whole kernel version, Linux kernel actually. Now the term comes, sir, what is this kernel? Kernel, what is this kernel? So nothing. It's like whatever the operating system which we're talking, it is nothing but it's a kernel only. Now you have here, you have an application or the user or the application. Here you have an operating system at the below. You have an operating system, or we call it an OS. And here you have a hardware. We know this architecture now, right? This is what we have been discussing from morning. Now, what Linus Torvalds said that this operating system, he coined the word by name kernel. He coined the name by name kernel. So operating system is nothing but kernel. Both are one and the same. In Linux world, on the Linux terminology, or in the Unix terminology, we say operating system as a kernel only. And this kernel is the one which has all these 5 components: file management, memory management, process management, device management, network management. All these 5 components are nothing but part of this kernel. So kernel is made up of 5 components. What are those? File management, process management, memory management, device management, and network management, like that. right? So your 95% of the code of the operating system, 95% of the code of the operating system, 95% of the code of operating system is nothing but it is kernel, and 5% of the operating system, 5% of the operating system is the assembly language, which even we call it as a HAL. HAL means hardware abstraction layer. Clear, guys? 5% of the code.
Rajesh, you are on mute, I think.
Yes, yes, sir. Sorry, yeah. So what I'm saying that 95% of the code of our operating system is kernel only, sir. So somebody told me, I think our Kiran has told that it is the heart of our operating system. Yes, it is the heart of the operating system. Your kernel is a heart of the operating system. You say. Kernel is a heart of operating. It's at the heart of operating system. And the whole code of this kernel is written in the C language only. Is written, the whole 95% of the code is written in the C language only. 95%, whatever we are discussing, right? 90%, it is written in the C language. So your traditional Unix operating system, it is written in C language. HPX operating system is written in C language. Solaris is written in C language. You take any traditional Unix operating system, even today Linux, everything is maintained in the C language only. C language is something like it is a mother of all language, we say. But also in a system level wise, C is a language even today also we use it for coding the operating system. Correct? But the C language was also used on Windows. You have heard about the Windows 98 or Windows 95. Windows 95 or Windows 98, they were actually written in the C language only. It was very quite surprising. Like some of you said, sir, what is it, sir? C language was never used by Microsoft company. How you are saying? Yeah, it was actually at the time Windows was written in the C language because the Microsoft company's chairperson, who is that Bill Gates and his team people, right? They designed this whole Windows in C language only at the time. But what happened slowly, what Microsoft did, no, they came up with their own language, native language. They designed their own language, and then they started using that native language in designing other operating systems, like whatever we have, right? Windows today, Windows 10 or Windows 11, Windows Vista, Windows XP, whatever we had the previous Windows, right? Those are all written in their own native language. But these two operating systems, Windows 95 and 98, was traditionally written in the C language.
MS-DOS they did, right?
MS-DOS also. MS-DOS was a very basic thing, but it doesn't had any GUI, right? But this 95, 98, right? It has a GUI. It was a complete, production-based or the based operating system. This was written in the C language only. So that 5% of the OS, whatever I'm saying, it is written in the C language, and that we call the HL, hardware abstraction layer. So why that code is used? So 95% of the code of your operating system is kernel only, which is written in C language. Yeah, this much of covered everything is C language only. Remaining this 5%, whatever, right? That we called as a HL, sir. That we call as a HL, hardware abstraction layer, and this is written in completely HL. It's completely written in the same language. This HL is the one who's going to actually communicate with your hardware, sir. So whenever a user want to interact with the hardware, the user will first communicate with the operating system. Operating system will communicate with the HL, and the HL finally communicate with the hardware. Like this, the flow goes. Clear? Good. Okay, this is how it goes actually. Okay. Now, so it is written in the C language. All other flavors of Unix were written in the C language. C is a ultimate, like programming language which is used to code the whole code of the operating system. Okay. Now, Fine. So that's all about the Linux. And what happened? Linux was code was uploaded into the kernel.org. And like Linux is an operating system. It is not like that you only give the Linux as a machine operating system and give to the other people to install and make it run. No, you need a lot of application. You need a lot of supporting libraries. Everything you need to have to make sure that it becomes a complete, installable image where you can install and start working on that. So what happened, right, during 1992, 93, a lot of distribution came into existence. A lot of distribution, Linux distribution came into existence. A lot of Linux distribution came into existence. So one was very much, the first was Slackware actually. Slackware was one of the very big organization distribution became. What the Slackware did, no, they downloaded the Linux kernel from the kernel.org, right? And the Slackware organization, what they did, no, they came up with their own they came up with their own application libraries, they designed and developed it. They made it to integrate everything together. And finally, what happened? They created an ISO image, and they burnt that ISO image, burned the image into the CD-ROM, CD drives, CDs actually, into CD, and started distributing to the companies, to the corporate worlds, and to many people. Distributed to the companies like this. This was one of the big distribution, but it was not there for a long time because it was superseded by one of the very big company which you have heard by name Red Hat. Red Hat was a very big company which was started in US, and they ruled the whole market, Linux market, because Red Hats are very much favorable in when it comes to server level, right? The whole server design and everything, set up everything, Red Hats are very much favorable. Red Hat, they are very good at servers. So that's the reason what happened. The market was completely captured by the Red Hat company. So Red Hat company, what they did, right? They came up with initially with the Red Hat as a distribution. Red Hat 1, Red Hat 2, Red Hat 3, Red Hat 4, Red Hat 5, Red Hat 6, like that. Red Hat 8 up to Red Hat 9, they came actually. Okay. So it means that whenever you want to install Red Hat 9, they used to give some 3 CDs. You need to take first CD, you have to install it. Again, it will eject and last with the second CD. Take the second CD, again put it in a tray. Because earlier you used to install the operating system in the CD-ROM only. Nowadays we are installing everything to either through network or either through the network file sharing, or either through some bootp, or either through your pen drive. You can install the Linux, right, nowadays. So nowadays nobody does a traditional installation. All the image, everything is in one place. You need to just connect with that and then try to load that and install it. It is very simple nowadays. No, sir, Red Hat is not open source. I'll come in to that. Now, what happened? Red Hat 1, Red Hat 2, Red Hat 3, Red Hat 9, up to Red Hat. These were not open source. They were paid one. You need to pay a licensing cost for that. So whenever the companies were going for Red Hat, I still remember Red Hat. I still know many people, my seniors were discussing with me that Red Hat 9 was there up to 2006. After 2006 or 6, what happened, right? They came up with the naming convention RHL. Red Hat Enterprise Linux, actually. It is an enterprise version. So Red Hat RHL1, RHL2, RHL3, 4, 5, 6, 7, 8, like that, they started coming. So some of you might be working on RHL7 also. In my current company, I'm working on RHL7, Red Hat versions. And these are also paid versions. You need to pay a licensing cost. It is for per mission, actually, per mission. I think if I'm not wrong, the licensing cost charge around 6,000 or 7,000, if I'm not wrong. So it means for one mission, if you are installing Linux RHL7, right, you need to purchase a licensing of something around 7,000 rupees, and they will give a support of some 2 years, something like that support they will give you. So that 7,000 come along with the support also. Okay, so that's how it came. And what happened, right? Within a Red Hat company, they formed one more organization which they call the Fedora. Fedora, again, it's an open source. So they came up with the Fedora versions like Fedora 1, Fedora 2, Fedora 3, 4, 5, 6, 7, 12, 13, 14. So a lot of Fedora versions came. Even some companies are using the Fedora version, but Fedora versions are open source. There is no support is given by the Red Hat. Red Hat or Fedora community says that we don't give support for the Fedora. But for RHL, yes, because it involves a licensing, the Red Hat will give you the support for that. Fedora, they don't give it. But still, you want to try out your hands in understanding anything on Red Hat and all, you can't pay the licensing means, then you can go with the Fedora. Fedora, if you go to the fedora.org site, you can download any Fedora version, you can install and you can run. After this, guys, many other came. one more distribution by name Debian came into distribution. So Debian also very good distribution. And then there's one more distribution by name SUSE came into the picture. Okay, SUSE was acquired by Novell, and again I heard Novell is acquired by some other company. I don't know. SUSE is also one of the distribution which is popular in Europe actually. Countries like France, Germany, many other European countries, they use the SUSE distribution, Linux distribution very much, right? And you might have heard about one more important which is Ubuntu. There are many other. Knoppix is there, Bluefish is there. You might have heard about Kali Linux. There are many Linux distributions are there, right? Which came it, but most favorable popular are Red Hat, SUSE, and Ubuntu. So these are the different distributions actually. And in Ubuntu, you have again many more flavor. I'm not discussing those things, but you can understand. Okay, Unix, Ubuntu is also one of the most. Yeah, CentOS also it comes under the part of Red Hat only. Red Hat, it's an open source. It's freely available. But as I said, guys, CentOS is not. I mean, the support is gone now. You will see another within another 2-3 years, it'll be obsolete. So, no one will be working on CentOS because almost the support is stopped now. So nobody is doing any kind of a development activity on CentOS. Clear? So we will be using in our sessions, like we'll be using CentOS 7.9 and we'll be using Ubuntu 22 version. These are the two flavors of Linux which we'll be doing. So now, if you ask me what is the difference between Unix and Linux, there is not much difference. But what happened, because Linux, the Linux architecture, it's completely dependent upon the Unix architecture only. Whatever the Unix we have, right, the whole architecture was redesigned again in the Linux actually. But Linux has much more enhanced feature compared to the Unix. Hence, what happened, right, once the people started working on Linux, most of the companies who are using Berkeley software distribution, BSD1, BSD2, or else SCO Unix, a lot of some companies were using SCO Unix and all. Those are very traditional Unix operating system. So they came out from this using this operating system. They switched to the Linux because they found a lot of new features, whatever they need in Linux compared to the previous Unix flavors. Hence, what happened, the company started slowly shifting. Now you see in today's world, at this current time, right, nobody is using Unix. You will not find anyone using the Unix or BSD, Berkeley distribution Unix or SCO Unix or some other Unix operating. They are not using at all because, I mean, no development is going on. Nobody is even maintaining also those things. So it is almost gone because Linux has grabbed the whole world actually. So whatever things were missing, right? What are the new features which the people need, right? You will get everything on Linux itself. And Linux is very much active, and it's a very big forum. A lot of people are involved in development of Linux operating system. A lot of new features will be keep coming up every once in 6 months, right? And every once in 9 months, like the new features are coming. A new kernel version is released by the kernel.org team. So like that, a lot of development activities going on. Clear? Okay, so guys, this is all about some basic understanding about the background about how the Linux came into existence. I didn't go in very in detail because that is not required for us. If you are very much passionate or you want to really go into it, you will find a lot of articles in Google where they have explained elaborately about how things happen one after the other, so that you will, if you go to the article, you will really enjoy reading all those things. But I said in a very high level, I told about how this came into existence. Okay, now. So the Linux came into existence, and a lot of and this GCC compiler, whatever the Linux kernel we have, right, that was took from our kernel.org, which was designed by Linus Torvalds, right? And then they integrated with GCC compiler along with this, because GCC compiler again was written by Richard Stallman, where it is an open source. And one more, there are a set of few people within the Free Software Foundation. They designed this Bash shell also. Bash is a shell. It's a default shell, or we can call it a Bash shell actually. And a lot of libraries were there, standard C libraries were there, which were written by many people. All this thing together, guys, they took the whole thing, they created an image of this, and they started selling. So the whole operating system, if you take any operating system, it has all these components within it. Means it is a mixture of both application and the compiler and the middleware and the Linux kernel. Everything together, it will be giving as a package. So you need to take this everything, make it as an ISO image, create an ISO image, and take that image and install in your machine. You take any companies like Red Hat or SUSE or Ubuntu, they will do the same thing. Standard libraries, plus a lot of applications will be written. Like, for example, you have a Red Hat. Red Hat are very favorable for the server applications, right? Suppose you want to install a lot of servers. Suppose in your companies you want to
Sir,
set up the. Yes, sir.
my apologies. I missed the last point, Linux kernel 145 line. Could you please explain that again?
No, what I'm trying to tell here is that when the Linux kernel came into existence, like when Linus Torvalds, he designed the Linux and he uploaded the Linux into kernel.org, what this distribution did, they took this Linux kernel from the kernel.org, they took the GCC compiler, which is there as a part of the Free Software Foundation, because GCC compiler was written by Richard Stallman, and also there was a shell which was written by the Free Software Foundation. Even the bash shell, the bash was also designed under the same Free Software Foundation under the Richard Stallman itself. Richard Stallman, he came up with the Free Software Foundation, right, with FSF, right? Under that, there were many tools, compilers were all designed and they have kept. Even some libraries are also were written it. Everything was available under his organization. But only one thing was missing was an operating system, which was not there. Apart from the operating system, everything else was there. So what this distribution did, right? They took the Linux kernel, they took this GCC compiler and the shell, they took it with a lot of other libraries and applications, everything. They integrate all together and they came up and they convert it as an ISO image and take that ISO image and install in your machine. So they can start working on the system, or you can start working on the Linux operating system. This is the whole idea behind all the distribution. So all this distribution, what they do, they tweak the Linux kernel also based on their requirement. Red Hat will take the kernel, they tweak according to the requirement. Ubuntu distribution, they take this Linux kernel and they tweak it according to the requirement. They will come up with their own libraries, they'll come up with their own application, everything take together, make an ISO image, burn it, install it, and make it to work. So you might ask then, sir, why you need so many distribution? Because each and every distribution has its own flavors. Red Hat is very favorable to the server side. Suppose many companies who want to install a lot of server softwares, you want to install the DNS server, NFS server, NIS server, Squid server, Samba server, Mail server, Postfix servers. You want to install a lot of servers and you need to get all the services. Means if you go, sir, which is the distribution which is more favorable in the server side? You go with the Red Hat, they'll say. Because Red Hat is very strong with all these servers. So most of the companies, why they're going to Red Hat? Because Red Hat provides a lot of servers editions actually. It provides. So whenever you want to install any servers, right, Red Hat is the most favorable. Similarly, Ubuntu, like that. When it comes to the embedded world, a lot of people who are designing or working on embedded level, system level programming, they'll go with the Ubuntu because Ubuntu provides all kind of communities, a very big community it provides, so that you'll get a lot of easily accessible softwares, supports available in the Ubuntu for the embedded domain. As well as even for the server also, Ubuntu is most favorable. So a lot of companies will go for Ubuntu also, like that. Clear, sir? I hope that, guys, you are understanding, right? Are you finding it very difficult?
No, sir.
What about others, guys? Any doubts you have?
No, sir.
Okay, great, good. Thank you. So this is how the like distribution came, and they came up with their own distributions and they started making a lot of money from that, right? Okay, fine. Now, so at the very beginning, as I said, right, I'll be using CentOS. So CentOS, and I'll be using Ubuntu flavor of Linux, right? And I'm having my AWS account, so that I'll be logging into my AWS account and I will try to create these servers, because ultimately we start working on Linux, right? So I will be creating these two servers. So let us see now how to create the servers, and or how to create servers and how to log in. Let us see, and then we'll proceed further. Okay. Now, okay. So now let me do a thing, guys. Let me go to my for client side Linux use. For the client side, which Linux we use? Sir, always what happened for the client side, right? Well, for the front end side, most of the time what happened, we use Windows actually, because Windows is very much favorable. From the server side, at the back end, Linux servers are used actually. Okay. So, I mean, if you ask me, okay, again, like the most favorable Linux which is used is a Red Hat only, sir. Even like most of the companies, choose to use Red Hat only, because Red Hat you will get a lot of plenty of support we get it from them. So that's what this is one of the very favorable distribution which most of the company adopt when it comes to Linux. Some companies are there where they cannot, Windows Server OS is not used, sir. No, Windows servers are used, sir. In the front end, we are saying. In the back end, all your application runs, all your critical application runs everything in the Linux only. In the front end, in the front GUI, whenever you want to interact with the application, you will come with the Windows applications, right? You'll come with your application which runs in Windows. Because the customer is a client, right? They don't know anything on Linux. They might even not understand the command. So you need to give some kind of a front end for them. So that's everything designed in Windows only, like that. Yeah. Okay. So we'll be choosing Red Hat, CentOS as well as Ubuntu. So what I'm going to do here. Okay. Let me close this. So I will go with the my AWS account. So you know that you should have your AWS account. So I'm going to the console.aws.amazon.com. So this is the site actually. I already have an account, guys. So I'm logging into that account. So this is my some email ID I'm giving. And I'll be giving the password. And I'll log into my AWS Amazon. Yeah, this is my like the landing page. We call it our home page of your Amazon. Correct. So now here, if you go to the services, many of you already know this. You have a lot of services, right? For example, if you come down here, you have a services, right? Like for example, you have a compute service actually, right? If you have a compute service, if you click on the compute service, you could see that there is an EC2 service is there. Click on to the EC2. You'll go to the page where it will redirect to the page where you will see that this is the EC2 dashboard, right? And it is a EC2 dashboard. And here in this EC2 dashboard, yeah, good. EC2 dashboard, what to do, you have to go and you have to create the servers here. So many of you already working on AWS or Azure, you might be knowing all these things, right? So here what happened, what I will do, here something, there's a, you could see that there's something instance running. I'll click on this. Okay, nothing is running. I think I have some 2 servers. Yeah, it has been there, it has been stopped. Okay, so what I'm going to do, I'm going to launch a new server. So I'll go here. First, let me launch the CentOS. So I have to go to the server launch instance. Click on here in the launch instance. It'll take you to the page where you have to launch it, the instances. So launch instance, give some name. So let me give some name, something I'll give the CentOS OS server only, something I'll give it some name. Come down here, because CentOS, right, it has been obsolete. You will not, in the quick start, right, you might not get that entry actually. That's the reason what happened, right? You have to go to the marketplace or the community. So you could see that including AMI from the marketplace or the community, you have to click on this here. Click on here. And if you go to the community AMI, click on community AMI. In the community AMI, if you're a community AMI, you can search for CentOS 7.9, something 7.8 or 7. Just enter 7.8 or 7. It will show you all the CentOS flavor here. See, CentOS, viewer, verified providers. Okay, I will come down here. CentOS 1 is there. Okay, I'll go with the CentOS 7.8. Let me check if there is any CentOS 7 is there. Okay, 1 second. Where is it? 7.9 is there. So I think I can select this one, or let me check other thing. Okay, let me only search for 7, CentOS 7. Okay, USTS. Okay, CentOS Stream 8. This is CentOS 8, but yeah, you can select even this also. Okay, let me check if I'm getting 7.8, because that was most highly stable CentOS operating system. So I was looking for 7.8 Enterprise CH. I think I can go with the 7.8 version. So I will select this actually. So once you select this, so you have selected the AMI of your CentOS 7.8. which has been verified. And okay, this is verified. It's a community edition. Okay. And I will go with the T2.micro instance, because this is, I'm under free tier. So I will go with this, because guys, when I'm practicing on Linux, I need not to have a very huge computing. I don't need it at all. Okay. So, okay, fine guys. That's fine. Okay. So you have selected the T2.micro. After that, here you can see that you have to create the key pair. So I can use an existing key pair. Already there's a key pair by name KTS, but I don't want to create it. I don't want to use the existing one. I will create a new key pair. So I'll create it. I'll just say create new key pair. So you have to always go with the RSA and you have to go with the PIM and you have to just say, you have to give the name also here. So I'll just say CentOS something. CentOS, I'll give that's all. That's the key name I'll give, and I'll just create a key pair. So once you create a key pair, so it will start getting downloaded. I think it has downloaded in my download directory. So if you go here and you could see that CentOS.pim has been downloaded, fine. And then if you come down, here what happened, right? It'll ask you for you to do some kind of a security group setting. Already I have a security group set in my system. So I'll go with the select existing security group, come over here, and I will give some my new SG. This is a security group which I have already created. So I will give this security group. And after that, is there any other things which I have to set? No. So what I have to do that, I have to give the name or the tag first, go with the community edition or the marketplace where you can go with the CentOS. So select the CentOS 7.8, and after that, go with the instance type and create a key pair. Create a key pair. So I'm creating a new key pair. Okay, and go with selecting the security group. So I have already created a security group. What is it? We will discuss after some time, but don't worry. But right now you understand, okay, I already created a security group. I'm just selecting that security group, right? And then like other things, nothing else. Okay. And then just say launch the instance. Launch where in order to use this, you need to accept the terms and conditions. Oh, okay, fine. Okay. I think I have to go with other flavor. Okay. I'll go with the CentOS server marketplace. So I can even search in the marketplace also. Okay, I'll go with the CentOS 7, CentOS 7, CentOS 9, CentOS 7. This one is better actually. Select this CentOS. It will charge me for 0.12 hour. That's fine. So you have a pricing for that. It is not under open. It is not on the free tier, so you have to pay the money. So I'll select that. Once you select that, I'll go with my T2.micro. Okay, that is sufficient. Key pair, I already created it. That is CentOS. I will give that key pair. And then in the security group, go with the existing selecting group, which I already created. Give the security group actually. My new SG. Okay. And then nothing else. Just go and launch it. So guys, any doubts you have? I think some were unmuted and they were trying to ask something. Okay. So similarly, so let this come up. I will go to the, okay, or let it come up. Let us wait. Because I need to even launch the Ubuntu also, right? So both the servers I will launch because I need both this.
Just take duplicate tab and create it.
Yeah, we can do it. I'm just showing you because some people, somebody will be new to this. Actually, they want to see it everything. That's what. So
Hi, Rajesh sir.
Yes.
Sorry to interrupt. Just a quick question. Why can't we use Amazon AMI for this?
No, anything, sir. It is. It doesn't really. I'm not restricted not to use. I'm just saying that because since most of you, right, will be working on Red Hat in the industry, right? So if you want to really understand a Red Hat or something, like if you have a knowledge on CentOS, it will be very good actually. Similarly, in many companies, Ubuntu are used actually in as a Linux operating system. So it is even to have a better knowledge on Ubuntu as well as CentOS, both. Clear. So now I'll go to the instance again. I think it'll create it actually. Okay, let it come up. Okay, I'll launch it again. Launch instance. So here I'll go with the name as a Ubuntu server. And I will select this Ubuntu quick start. It is showing here. Okay, I can select the latest one, 22.04. That is a free tier. Or else if you just highlight this one, you could see that you are having some previous version Ubuntu edition. Also, you have like 20.04 or even some other versions, but you can select the latest one actually. So this is the latest one, and always see that
So
you are selecting the
20.0, hello, sir.
22.04.
So 20.04, I think it is stable only, sir, like 20.
All are stable only, madam. All are stable only. All these are stable AMI only. They
Okay.
won't provide any unstable one. But this is the latest Ubuntu server, 22. This is the version of the Ubuntu server, 22.04. So I can select this latest Ubuntu server 22.04 version. Select this. So selected it, and you can make it everything work under t2.micro. That is fine. Because I am still under free trial, right? So free trial eligible. This is fine. And go and select this key, or either you can create a key, or else you can have the existing key only. Okay, let me go with the creating a new key. Like I'll go the new key. I'll give as a Ubuntu only as a key name. UBUNTU. Ubuntu, right? UBUNTU. Yeah. And I will select the PEM and let the RSCB. Let me create the key. So you have created a Ubuntu as a key. Fine. In the network setting, go to an existing selecting group. Go here. Select this one. Later, I will tell you how to create a security group. But right now, you understand that, okay, I'm creating an existing selecting group only. Or you can create a new security group. Other things, what and all you have to set, nothing else. Okay, everything is fine. If you go to the advanced details, is there anything which I need to really look into it? If you see it, okay, not really required. Yeah, I can skip this. Fine. Now, finally, you can launch the instance. Yeah, we can give the same key. You can give the same key. You can create 10 machine, 10 servers, you can give the same key. It doesn't matter. Key is basically used for authentication purpose. You want to log into the machine, right? You need a key actually. Okay, guys. So let me go here. I think CentOS is not been created, or CentOS is created. Yes. Let me do one thing, guys. I will try to this Kubernetes server. I have created these two servers, master node and worker node. Let me try to terminate it. So I'll select both these servers. Go to the instance state and do a terminate. I will just terminate these two servers. I don't need it. Okay, good. Okay, so these two servers are up and running. So you can just say instance state :running. So it'll only display those two servers which are in a running stage. So these are the two servers we have. Fine. So always please make sure that the status checks comes to some 2x2 checks, or it is showing the initialization, right? Now, here what happened, guys, if you go to your downloads, you could see there are two files are there. These are the PEM files, we say. PEM file. So these are the two PEM files which we have downloaded from your AWS console, right? While selecting it, you try to create a new key pair, right? Now, using this PEM also, you can connect to the Linux machine, okay? Or else, if you are using the putty, you need to always connect it to the PPK file, actually. So let me write down. So after creating the servers, you have generated key pairs. In our example, we have created key pairs with the name CentOS.pem and Ubuntu.pem. So you can log into the CentOS server using CentOS PEM file. Similarly, you can log into the Ubuntu server using Ubuntu.pem. Okay, so what are the different softwares are there? What are the different client applications are there through which you can connect to any Linux servers? There are many are there, but like for example, a few of the things, like for example, you have a Git bash. Using Git bash also, you can use it to log into the server. So login methods, how we can log into login methods or login, how I can say it, login methods, right? Now login methods. So first you can use the git bash. You can even use the putty. Putty is a software which we use it to log into any external server that is on that is a Linux servers, right? So many other things, right? So for example, you have a what else we have? We have one more, is there, right?
Mobile
Which
XML, sir.
mobile XML, yeah, mobile XML. What else? Many are there. Like for example, Super Putty is there. So there are many clients are there. By using any one of the client, you can actually log into the server, right? Now here in this Windows machine, guys, I have installed the git bash. If you go here and if you do a right click, okay, and if you show more options, see, can you see here git bash here, git? I've already installed the git in my machine. So you can download the git and install it actually. Yes, terminal command. Yes, correct. Okay. So what you're doing, what you have to do here, you have to go to the downloads because you are having a PEM file here in this. Here you be in this download folder, do a right click on here and just open the git bash here. See, this is a kind of a bash shell actually. This is a bash shell. So you are under the download directory. If I execute pwd, you will see that you are under download directory. So if you do an ls, you could see that even the PEM key, CentOS.pem or Ubuntu.pem, this is there here. So ls is a command to display all the files and directories in the present working directory. Correct? ls is a command, pwd is a command. So we will come across with few of the commands in our upcoming sessions. But right now you understand, okay, I'm just executing some commands. Now here what happened, right? Once you have launched this 2 instance and just refresh it, you could see that the 2x2 check passed. You should get the status so that you will be able to log into the server. Now, suppose I want to log into the CentOS, click on the CentOS, click on this button and go to the connect here. Can you see here? There's a connect by name connect. Just click on this. And here you could see that the default user by which you will be logging in is an EC2 user. So whenever you are logging to the CentOS or whenever you log into the RHL, the default user which will be is a EC2-user. But how to log in as an EC2 user into that server? There is something the SSH client. Click on here. Can you see he has given an example? Suppose you want to connect to this machine. You have to give this complete line. Okay. So now when you come here, guys, every machine or every instance here, if you see, every instance has both a public IP and a private IP. If you click on the CentOS here, can you see it is showing the public IP over here? Public IPv4 address, public IPv4 DNS name. Similarly, we have a private IP. So whenever you are connecting to any external Unix machine or any external machine, you should always give either the public IP address you have to give, or either you have to give the public IPv DNS name you have to give. Any one you have to give the name to log in into that server. So here, when I click on this, I got this public IP DNS name and the public IPv4 address. Any one thing you can use it. And if I want to have a complete command line to do it, what you have to do, click on here, go to the connect. And if you go to the SSH client, this menu, you could see they have given an example. So I can literally copy this whole example or this whole line. I can copy it, go to here in your git bash terminal, paste it and just execute this command. See, it is creating a fingerprint. You have to always say yes. And then you will see that you will be able to log in into this machine. Permission denied. Permanently added into it. Permission denied. Permission denied. Okay, we will see that what. Yes, sir.
Remove EC2-user instead of using CentOS. You can mention CentOS.
No, sir. You have to use EC2 only. This is the username. Username at the rate. You have to give the complete host name or the.
It will not connect.
Why it will not connect? It has to connect. Sir.
I think you need to give 777 permissions for that PEM key.
No. That is one troubleshooting, sir. You have to always give 600. Okay, we will see that actually. You don't worry now. So this is one way. Or else, okay, let me check whether we are facing the same issue here also in Ubuntu. Click on this Ubuntu. Go to this connect, and you could see that when you click on the Ubuntu, you could see that this is the public IPv4, and this is a public IPv4 address, and this is a public IPv4 DNS name. You can either use the DNS name or just a public IP. Anything you can use it. you have to connect it. But when you click on this and when you do a connect, and if you go to the SSH client, here you could see that SSH-I, and you're giving the PEM key, that is ubuntu.pem space ubuntu at the right, and specify the DNS name actually.
Observe Ubuntu is the machine name.
Yes, sir, correct. For the CentOS, it is EC2-user. If you connect here, and if you go to the connect, if you go to the EC2 instance connect, can you see here the default user is EC2 user? It is not CentOS.
But it will not connect. Yeah.
It will not connect. It will not connect with CentOS. It is not like that. CentOS is not the default user. EC2-user is a default user. So come over here. Now what happened, right? You will go to the Ubuntu, connect it. We will see whether it will work or not. Okay. And then copy this whole line, entire line. So I will go here. I have this git bash. Let me give this complete git bash here. So command here in your git bash shell here. Enter. Let's see whether it will connect or not. Yes, you are able to connect to the Ubuntu server. We'll see why it is not getting connected to the CentOS actually. So I have connected to my Ubuntu server actually. Clear? So this is my Ubuntu server, and I can execute any command like this. This is the terminal actually. So whatever I have logged in, it's a terminal actually. Now, similarly, how I can log in through the other way. Suppose I have a putty session. Some of you are used for logging as a putty session. So for the putty, you need to download two softwares. One is a putty and other is a putty gen. These are the two softwares you have to download it. Where to download? Go to the Google. Just say putty download. You have to give a putty download and enter. So when you go to a putty download, you could see that there is one. There is a site by name. Let me check whether it is the same site. No, this is not that site which I'm looking for. Even you can download from here also, but I'm looking for that particular site actually where you can download it. So sorry, putty gen. No, not this one. Putty download for Windows. Okay. Where is it, sir? I was looking for that particular site actually where I can download it. Why it is not displaying like this? Region. Not this one. Where is it, sir? That site was very good actually. Where even what is that site name? I have forgotten. Yeah, this is what. Yeah, this is what I was looking for. So this is a site actually. So I'll copy paste this site, and I will give. This is a site where you need to download. You need to download. What you have to download, guys? You need to download both putty as well as putty gen. Some people call it as a putty, or you can call it as a putty. Putty and putty gen both have to be downloaded from this site actually. Yasmin, yes, we can do it. I'm not saying no. Yes, key permission should be 400, right? That's what I was coming to that point. Ram Prasad, you're right. So Yasmin, you can do it, but already I said earlier, right? Because first you try to concentrate on what I'm doing, and then you can practice at your place. And if you have any doubts, you can get back to me. And you can watch this recording also to do your practicals, whatever you want to do, right? You can achieve. Because if I start waiting for everyone to complete their practice and everything, this will be too much actually. We will not be able to complete the whole course actually. That's fine. Okay, that's fine. Okay, that's fine. So please try to understand whatever I'm saying. So you need to download the putty and putty gen, guys. And then what I have to do here, whenever you want to use this putty always expects to have a PPK file actually. Okay. Putty expects always to have a PPK file. Hence what happened, right? You need to generate the PPK file out of this PEM file. How to generate it? There is something as a putty gen is there. You just double click on the putty gen. It will show you, it will launch it. Here there are two things you have to do before you starting converting. You see that there is something like key is there. Go here, parameter for saving key or 1 second. Yeah, parameter for saving key is there. Once you click on parameter saving key, private key parameter should always, the PPK version should always be 2. So let's select as a 2 and say okay. Okay. Later what happened? What are the type? Let it be RSA only. Don't do any changes to this parameter. Let it this be always with the RSA. Then what happened, right? You have to click on this. You have to just say load actually. Load it. So what you have to do? You have to give the all files. Click on this CentOS.pk. Open this, and then save it as a private key. Okay. And then sorry, I think I have to give a public key. I'm sorry. Save it as a public key. Okay, and give all files and give the name as ppk. So select this CentOS.pem, just rename it to ppk and save it. So you could see that a file by name CentOS.ppk file got created. So this is what I need whenever I'm using a putty. Actually. Okay, fine. Again, now next I have to do for putty.pem. I have to generate a ubuntu.pem. I have to create a ubuntu.ppk file. So let me close this again. Launch again this putty gen. Go to the keys. Go to the use a strong parameters for saving these key files. Click on it here. Select the ppk file version as a 2 version and say okay. Okay. Then again click on this load. Select this time. What I have to select, guys? You have to go with all files. Select the ubuntu.pem and say open. Okay. Save as a public key. Click on this. Okay. ubuntu.pem. So, but you should give with the name ppk. So I change from the pem to ppk and just say save it. So can you see here that it has generated or it has created 2 files. One is a ubuntu.ppk file. Other is a CentOS.ppk file. Krishna, it's a putty private key, right? Yeah. Oh, yeah, it's a private key, I think. Yeah, I did a mistake. Fine, let's see if I did any mistake, I will get to know. Okay, so what I'll do, I'm going to log into this service. Yeah, I think what you said is right. I'll generate it again. So I'll go to this instance. Okay, I'll click on this CentOS servers. I think it is, you're having a public IPv4 address. You can copy this public IPv4, and you know that for login to the EC2 machine, log into the server, you need to always use the EC2-user. That is user. Copy this IP address, public IP address, and go to your downloads where you have the putty. Launch this putty actually, and just paste this IP address here, public IP address here. And you are having SSH key. Okay, there are some settings you have to do, a very basic initial settings you have to do. For example, you have to go to the keyboard. You have to check, is there any setting you have to do? No. You have to go to the bell. Do you want any bell when you are doing it? Okay, none. Bell should be disabled, fine. And after that, is there anything you have to check for the features? Nothing is there. Behavior, okay, I don't need anything. Appearance, I can change it to some higher size, like I will select as 18 and make it as a bold, right? And say okay. And if you go to the colors, yes, you can do any kind of settings. I will setting as a default color as the background. Okay. And then I want to give the ppk file now. So because I'm logging to the CentOS machine, right? I have to go to under the connection, you have SSH. Under the SSH, you could see there is something like a auth actually, right? Under the auth. Under the auth, you have credentials here. Okay. Is there anything I have to give here? Certificate to use the private key. Okay. Under the auth, do I have to give anything? No. Here under the hotkeys, cipher, no, nothing. Credentials, yes. Certificate to use it. So this is the ppk file, private key for authentication. So you have to change it to, you have to say browse, and you have to give here as a CentOS.ppk file. Clear? And after that, anything else? Nothing, sir. That's all. So what you have to do here, you have to give the public IP here, and I have went to that bell and I have disabled the bell notification. And afterwards, I did a color settings. I changed it to default foreground. Use this as a system color setting. Go to the SSH. Go to the connection. Under connection, there's an SSH. Under that, there's nothing more auth. Under auth, there's a credential. Click on the credentials. Select the PPK file of your CentOS because you have to log in as CentOS, open it actually. And I mean, select that one and then like you go to the session and just say open it. So, and then here you have to accept it. So here you have to give EC2 -use. Yes, you cannot do it because I wrongly did it. Krishna, what you said is right. Sorry, I think in a hurry I did it. So what I have to go it. What I will do, I will try to remove these two files, CentOS.ppk and ubuntu.ppk. Both I will delete because you have to create a private key, not the public key, right? So I'll launch the putty gen again, go to the key, parameter for saving key, select the ppk2 version as 2 and say enter. Okay. Click on the load, select all files here, select the CentOS.pem file. Okay. Save it as a private key, not the public key. Save it as a private key. Let's say yes. And you give the CentOS.ppk file here. You're creating with this file name. Yeah. So I think CentOS.ppk file got created. Yeah. Same thing you do again because already the key is already you're set as a 2 version. You need not to redo it again. Select on load. All files, select the ubuntu.pem, open it. This is a one-time activity, guys. After that, you need not to do again. So save it as a private key. I'll say yes. And then like you can select the ubuntu.pem, but you need to give the name as ubuntu.ppk file. And I'll say save. So you could see that I have created these two files. So let me close this putty gen now. So now what I will do, I'll do the same stuff. Launch the putty. Give the public IP address of CentOS, copy the CentOS IP address, paste it here actually. And then I have to do little bit settings. Okay, disable the bell. Okay, color, give it as a foreground. Okay, and if you are having any behavior or appearance, I can change the appearance. I'll go to the 18. I will not make it as a bold, I'll make it as a regular only. Okay, and this is the font type. Okay, let me go with this only. Okay, and then say okay, fine. And afterwards, color I have set everything, and you have to just expand the SSH here under the connection. Go to the auth, under auth you have credentials, click on this here. Here again you browse it, give your CentOS.ppk file, open it, and again you can just see that okay, you have given it, yeah, then you say launched. Here you have to give as a EC2-user. Okay, server key, something happened, guys. It has refused our key. Let me try out with the Ubuntu. Select on the
You
Ubuntu.
don't have to give .ppk. It's a wide. It's converting by default to .ppk.
It is. Sorry, come again.
I think you type .ppk, but you select .ppk. It's a by default. Create that file.
No, you have to give us a ppk only, sir. See, ppk file you have to give. ppk file. Yes.
No need to give .ppk. It's convert on by name only.
You have to give the ppk, sir.
Automatically it took Rajesh.
It's automatically create a .ppk file.
Oh, is
Yeah.
it?
Yeah. No need to give any extension.
But it was okay. Okay, let us see. Okay, let us check because
try once again.
Yeah. So let me log into the Ubuntu. So I'll copy the public IP of the Ubuntu server. Go here under the download. Let me close this one. Okay. Go to the download. Launch the putty. Give the public IP. Bell. Okay. Order of appearance. Okay. I'll go as 18. I'll make it as a bold this time. Color. Let me go to the foreground. Let me give an SSH. Credentials. Let me select this. Let me give ubuntu.ppk file. Okay, and then say open it. So I will be logging as a Ubuntu. Yes, you log in. Okay. I think there is some issue, sir. We'll see what is it actually. So CentOS, I'll check 7.9, right? I use, right? There could be some issue actually.
For CentOS, there is some issue with machine side only, Rajesh. Even I have faced the same issue.
Same thing. Yeah, I think so. There could be something because, but yesterday I tried out actually. It was working. Which version I have forgotten? 7.9 I used or 8 I used.
Yes.
I'm able to log in, Rajesh.
You're able to log in. Good, sir. Which one? CentOS 7.8?
Yeah, 7. I'm not using EC2 user. I'm using CentOS username. Then I'm able to log in.
CentOS, how come, sir? CentOS is not EC2 is a username. Okay, let us see.
Try it. One
Yeah,
minute.
try it out. What is there in that? Yeah. I'll copy the public IP. So I'll open the T. Oh my God, how is it, sir? How is it possible? CentOS.
It's the username CentOS, not EC2.
Yeah. EC2. How come they're showing here as a client as a EC2-user? Here also it's showing as EC2-user. Enter the name defined in the AMI.
You are trying to log in root user. That's why it's not able to log in.
No. I was logged in as a EC2 user only. You saw, right? I give as EC2-user. Okay, fine. Anyhow, thank you. I think, yeah, you have to use CentOS as a user. Yeah, you'll be able to log in it. Right. So now we have these two servers actually, right? Now, if I want to understand, or I want to see you are under which flavor of Unix or which flavor of Linux actually, there is a file. Try to understand now. There's a file by name etc lsb release. This is the file which is used in Ubuntu. If you execute this command, you could see that it will show that you are under Ubuntu and the version distribution was 22.04. So this is the command we will be running. So basically I'm using a cat command to display this file content. So this is displaying. Okay, fine, good. Let me copy this. So, and I will try to paste it here. Okay. Similarly, if you come over here in the CentOS, you have a file with the name Red Hat-release. This is a different name. If you enter it here, it will show you that, okay, you are working under the CentOS Linux release 7.9. So you are working on CentOS operating system. Like this, you'll get to know. Clear? And if you want to check on which operating system or which kernel version, sorry, which I'm working under, there is a command by name uname command, right? With the -r option. If you enter it, it will show you that you are working under your Linux kernel version for this Ubuntu 22 is 5.19. This is the kernel version. Okay. What about the CentOS? In CentOS, if you go over there and if you execute the command CentOS, uname-r. Oh, it is very old kernel version, sir. 3. Because this is a very old distribution, right? And since that's the reason they're using a very older kernel version, that's 3.0. 3.0, I remember it. This kernel version was used in 2008 or 2009. This version was used actually, right? So we just executed certain things to get the output so that we'll be able to understand what exactly it is. Uname command is basically used to display the kernel version. And this file, etc lsb release, this is a file which has information about the distribution, which Linux distribution. So when I do a cat on this, what is cat means? Cat is basically a command which is used to display the file content. Right now you understand in this way. Cat is a command which is used to display the file content. So when I'm executing this command, it is showing me this output actually. Same command. If I'm doing cat etc, there is no file by name lsb release. There is a file by name Red Hat-release when it comes to CentOS or RHL or Red Hat. So you have to always execute, you have to always open this file to see the distribution version. Is it clear?
Hi Rajesh, can't we see via the command instead of opening the file?
Yeah, you can do so. You can execute the uname-a.
No,
Uname,
for Linux distribution version. Okay.
uname-a. Uname-a also will give you some information. You could see there's a Ubuntu. So through this also you will understand, okay, it's a Ubuntu server. Similarly, if you come over here with the uname-a option, you have to execute so that it will show that it is a CentOS. Here you could see that it is not displaying CentOS. That's the reason what happened. It is always better to open this file so that you'll get complete information. uname-a, apart from this kernel version, it will display many other information also, like which is the Linux, what is which architecture it is, SMP architecture, what are the different processor, when that when that operating system was created, what are the different processor it supports. Like that, uname-a will give you more elaborate information apart from the kernel version. Suppose you want to only display the kernel version, uname with a -r option, you have to use it. Okay, guys. Okay, so now, so we have logged into these two servers, and we'll be running or we'll be executing all the commands or scripts, everything in under these two servers only. Clear? Now, okay. So this is all about how to log in it. So I expect you should have the accounts, and you please create the machine servers, and you practice everything in, and you need not to go for very high configuration. Go with a very basic menu configuration, because the Linux can run in a very basic configuration also, so that you can practice everything, and you won't get that kind of a billing also. Because if you are under free trial, it will be under completely free. You can practice all your Linux concepts, everything under the free trial itself. Clear? Now, what are the important things? What are the other things which I have to understand? Okay, let us discuss something on known as what is a user space and what is a kernel space. User space versus kernel space. Let me check. Yeah, you can log in through AWS also. Yes, we can log in through AWS server also, right? Yes, Ram, we can connect with both. That's what I said. Like whenever you're connecting to putty software, putty doesn't understand the .pem format. It only understands the .ppk format. Hence, I generated the .ppk from the PEM, and I logged into it by using the putty software. Okay. So, guys, any other questions you have apart from this? See, now whatever we got the terminal, right? We got the servers to the terminal. You cannot explore all the features about the Linux with your cloud with the cloud servers. No, you cannot do it, because here what happened, right? You are only logged into the server and you're doing a few stuff. I mean, you're executing some commands, you're going through some file and everything. Suppose you want to completely understand everything about the Linux concepts and everything, right? It is always better to have one virtual machine. So if you have installed some third-party software, like for example, Sun VirtualBox or VMware Workstation, you have installed it, and on top of that, you are installing the VMs, you will get the better control of your operating system. So you can do many things. You can even understand the boot process. You can even understand that once the machine is switched on, what are the activities it takes place, how it get booted up. So many things you'll get to know. What are run levels? How I can reboot the machine if I reboot the machine? How I can get the BIOS prompt and everything. You will get the full control if you have your own local VM in your system or in your laptop. But here in the cloud, what happened, right? You will not get that kind of a facilities. Because here what happened, right? For every server, right, they will be giving only one terminal. You have to just log into that server with the help of a public IP and with the help of a key. You're logging in it and you are getting some kind of a terminal like this. This is a kind of a terminal also, we'll say. So through this terminal, you can interact with an operating system with the help of by executing some commands. Clear, guys? Yeah, I've already shared. Okay, you want this to be shared here? Yeah, I will share it. Yeah. So you can copy this link. Yes.
Rajesh sir, how to upgrade the kernel version in Ubuntu or Red Hat?
Yes, sir. I'll come with that upgrading also, patch management and upgrade and all. Like you have whatever the commands you have, no, sir. Like for example, in Ubuntu, you have a apt actually. When you do an apt update, right? Apt update will always try to check which is the latest kernel version available. So if it will show that this is a kernel version available, latest kernel version available, you can update it also. Similarly, you have a yum update in Red Hat or in CentOS. If you run a yum space update, right, it will show, suppose you're having 3.1 and the existing one is 6.5. It will try to download the 6.5 and install it.
So to upgrade the kernel version, we need to give the command yum upgrade, right?
Yeah, yum upgrade, not upgrade. Upgrade actually. Yeah. Yum upgrade.
Okay.
Same, Priya. in this link, yes, guys, if you go to this link, sorry, I didn't see. If you go to that link here, if you come down, can you see here? There is something was a putty.exe. Please always try to download the 64-bit x86 putty.exe. This is the one which you have to download. And if you come down, can you see something was a putty.gen, puttygen.exe? Puttygen.exe also you need to download the 64-bit x86 because my laptop or our laptops are x86 processor. You shouldn't download the ARM or you shouldn't download the 32-bit. No, it will not work. Please download this. So you have to download the putty.exe as well as you have to download the putty.exe. Puttygen and putty.exe, both this has to be downloaded. Is it clear? If you just click on it, it will start downloading, sir. Okay, fine. Sorry, I missed it out. Okay. Coming here. Yeah. Now, this is a very important concept. Like all of us have to understand about this, what is user space and the kernel space, because this is also a kind of a stepping stone, which we will be understanding about the operating system. Now, with the help of this user space and the kernel space, you will be learning many things. One second, guys. I think somebody has pinged. Okay, fine. Yeah. So let us try to understand what is user space and kernel space. Very important. Okay, now let me open MS Paint to make you understand. Guys, now what happened, right? Suppose, for example, whenever you're booting a system, you know, right? Like when you have a laptop and you say, Rajesh, I'm having a Windows machine in my laptop. I want to just run my operating system. What you're going to do? You're going to just first power on the system, right? You'll just plug in your charger to the machine laptop, and then you just have a power button. You're going to just click on that. As soon as you click on it, you know that the power goes to the system or to the hardware, and some kind of a initialization will happen at the initial stage, means initializing all the hardware which is connected to the system and everything. Finally, what happens? Some kind of a booting takes place. The booting of your operating system takes place. Finally, you will see that something is getting displayed in your screen, right? And you will see that kind of a login page will come where you can log into your machine by giving some username and the password. So starting from switching on to your system by switching on the power button to the up to the place where some kind of a login page will come, right? This entire process, we call it as a boot process. We call it as a boot process. It means the boot process is not about booting your system. It is not about loading your operating system into the machine. That we call it as a booting. So this booting process, it differs from one operating system to other operating system, because Windows, it boots in a different way. Linux boots in a different way. Mac OS boots in a different way. To boot it, to make the operating system up and running, you need always you need a bootloader actually. So you need a bootloader. So there are bootloaders are there. Like for example, in your Windows, right? In your Windows operating system, in your Windows machine, you have a bootloader by name NTLDR bootloader. This is a bootloader, guys. Bootloader is a special program, okay, which is called by your BIOS to load the image of an operating system. Similarly, in Linux, you have a bootloader by name grub bootloader, Grand Unified Bootloader, we say. Earlier, there were bootloaders by name Lilo, Linux loader, but now we are not using. I'm just telling you for information. So grub is a default bootloader which is used in Linux actually, Linux operating system. Okay. So now what this bootloader does? Bootloader, it is a special program. I mean, it is a special program invoked by your BIOS to load. Why this is going like this? To load complete image of your operating system into the memory. That we call as the bootloader. So now what happened, guys? If you have your laptops here, So this is your laptop. This is your laptop, right? You have a laptop key. So now what happened, right? As soon as you power on your laptop, right? So within your laptop, okay, there is something known as a BIOS. Have you heard of BIOS, guys? What is this BIOS chip? What is this BIOS? Can anyone tell me? If you have any information on BIOS, what is it? It is actually a chip which is there in your motherboard. So you have in your laptop, there's a motherboard, right? Within the motherboard, there is a BIOS chip is there. In this BIOS chip, there is a programmer, there is a software, we call it as a firmware, actually. We call it as a firmware. This BIOS chip, it has a firmware. And it has all the basic level drivers, very initial basic level drivers, very basic initial level drivers are there, right? There are some interrupt routines are there. What is it? We need not to really know all these things. Okay, there's something like interrupts are there. What else? Other things? What other things? There are some kind of a IPC mechanism is also there. So this is what your firmware contains. The firmware contains a combination of all these things. It contains the basic initial low-level drivers. We call it the low-level drivers. We have some kind of interrupts. We have some kind of IPC routine. So many things are there in BIOS. So what we say, actually, technically speaking, BIOS will do a initial bootstrapping. Initial bootstrapping is done by the BIOS code. Now somebody might ask you, sir, BIOS only, I'm not understanding it. Sir, BIOS is like a chip, sir. Earlier, this chip was actually designed by the Motorola company, actually. BIOS chip, actually. BIOS chips by Motorola. Image. This is the BIOS chip, actually. This is the AMD, this is the BIOS chip. This BIOS chip does an initial bootstrapping. As soon as you power on the system, this BIOS will get initialized. And this BIOS has a lot of pins, right? All these BIOS are BIOS, right, has a lot of the pins, actually. These pins are actually connected to your processor. So as soon as the BIOS is initialized, even your CPU is also initialized. And many other hardware devices, whatever connected in your motherboard, everything will get initialized. Like, for example, your RAM will get initialized, your hard drive will get initialized, your audio driver, video driver, graphic driver, what are all the network driver, what are all the devices which are connected to your system, right? All we get initially, it will get initialized during the boot up time. That's what I said, that this BIOS has some basic, very initial drivers. Have you seen? Guys, I wanted to ask you one question. Now, for example, you can even boot up your operating system even from your USB also, right? But you will say, sir, I'm going to get all the functionality of the USB once my OS is up and running. But you see that when you connect the USB stick into the USB slot in your laptop, or if you have a CD-ROM and if you insert the CD into a CD-ROM, you could see that you can even boot it from your CD-ROM also. Now you might ask, sir, operating system itself is not there. How these things is getting detected because BIOS has a very initial low-level drivers which can actually communicate with all the devices, even though there is no operating system at the very initial stage. Still, the BIOS can detect and it can communicate with these devices. How it communicates with the devices with this concept of interrupts, we say. What is it? We need not to learn about all these things. Interrupt is some kind of a signaling mechanism through that it communicates. Like that, you have to understand. So once this BIOS will get as soon as you give the power, the BIOS will get initialized. The BIOS is going to call all these low-level drivers, right? And if this whole phase, we call it as initial bootstrapping. Okay, fine. After that, what BIOS will do? BIOS will give control to your bootloader. If you are working on Linux, grub is a bootloader, default bootloader. What the grub will do, sir? Grub will take the image of an operating system. It takes from where it will take from the bootable device, or it will take from the bootable partition, or the partition where the image is there, right? From there it will pick it up. This image, this is nothing but your operating system image. OS image or operating system image, a compressed operating image, it will take, and what the BIOS will do, sorry, what the grub will do, it will take this image, the whole thing, and it will try to load into your RAM memory. This is your RAM memory. This is your RAM. RAM, you know, right? RAM is a primary memory. RAM is a memory. So what happens that it's going to load this entire OS image into your RAM. This OS image will be loaded here. So your whole compressed image, OS image will be there in your RAM memory. Once this compressed image is loaded, okay, once this compressed image is loaded, this OS image will get uncompressed. This is a compressed image, but it will get uncompressed. Once the image is uncompressed, then what happened? The whole operating system will be loaded. Your whole kernel will be loaded with it. After the extraction, the whole OS come into the picture. Actually, operating system come to the picture. Once operating come to the picture, you see that you'll get some login page. You'll get the page here like this, where you have to provide some username and the password. So till this whole phase, we call it as a boot process. Actually, we call this as a boot process. So do you have to really go in detail about all these things? Sir, being a DevOps engineer, you have to learn. Not really required, sir. But for your knowledge sake, I'm saying this whole process. This whole process we call it a boot process. I mean, the process is very huge, sir. I'm just telling a very high level. If you see the boot process, right? If I want to really do a boot process, initially BIOS. Second step is BIOS. Second step is bootloader. Hey man, what is happening? Bootloader. Third is nothing but the setup code. And now you'll ask, what is the setup code, sir? No, don't worry. Setup code. Fourth step is startup underscore 32 code. And finally is start underscore kernel. This is what the routines are. It is getting called to boot the complete booting. But in a very high level, I'm saying this is how it happened. But how this and all everything will happen, there is internal functions. These are written, sir. These functions will get called. So by executing these 5 steps, right, the booting or the image of your complete operating system image will be loaded into the memory. And later uncompression will happen and the whole operating system will come to the picture. This whole phase is taken care by these 5 steps, sir. If you go to your Google and if you just say Linux bootloading, you can even give plus IBM something. Booting Linux, right? See, okay, booting control points. Okay, something has given booting Linux in LPR. Okay, come down here. I think this is not that article. I was looking for some other article. Linux, not bootloading. No. Linux boot process plus IBM. Boot process. Okay, RAM memory. Oh, not this one, sir. I think that's those articles. I don't know whether it's there or not. Linux boot process step by step can give. You'll find a lot of articles, sir. Can you see here? This is for geeks. This is good article. Boot process in Linux, 6 stages in boot process here. See, BIOS, MBR, grub, kernel, init, run level. But this is a very high level they are given. But if I want to tell you in a very deeper way, see, grub is getting called, that's a bootloader. So it is calling a startup underscore. I think they have not executed, and they have not told all these things, sir. MBR, grub, kernel init in run levels, startup, right? All this kernel initialization, all this different stuff happens here. Lilo bootloader, system core, EFI Linux, okay, grub. No, sir. I mean, they have removed it, I think. It's not there actually. I used to read the articles. Step by step. Sure. Startup underscore 32 start code, that everything is there actually. So they made it more simple, sir. But whatever I said is this way. right? The grub bootloader will get called, the kernel initializer happens, and finally the operating system will get loaded, and you could see that the first process, the init process, will get called like that. I'll be discussing this init process and all. So what I was trying to tell here, that this is the 5 steps which are getting involved to completely do the complete boot process. Now, why I told about all these things? Why? Because that, guys, now this is a simple, this is what the boot process, but actually what happens internally, you know that during the boot process, when the grub bootloader is loading this operating system image, before it loads the operating system image, if you take this whole RAM memory, the whole RAM memory, so if I take a whole RAM memory like this, if I take the whole RAM memory like this is your RAM memory. This is your RAM memory. Your RAM memory. RAM is not but your primary memory. RAM memory like this. This RAM memory, what happened during boot process, this RAM memory will get literally divided into 2 spaces like this. One is called it as a user space, and the other, the downwards, it is called as a kernel space. Very important, user space and the kernel space. Now, during boot up time, what the grub bootloader will do, the grub bootloader will load the image of our operating system, OS operating system, into the kernel space of the RAM memory. This is the whole RAM memory. The RAM memory is given to user space and the kernel space. So what the grub bootloader will do, it will take the OS image and it will try to load that OS image into the kernel space of the RAM memory. So here that compressed image of an operating system is loaded actually. And the compressed image of the operating system name, usually the name would be VM Linux image. We will come across with these things later. What is the VM Linux image? But right now, try to understand, okay, your compressed image of your kernel or the operating system, the name will be VM Linux image actually. This is your compressed image. Compressed image. So who is going to load this compressed image into the kernel space of the RAM memory? Your grub bootloader. During the boot process, it loads it. Just try to relate with this diagram. See, when you're booting up, initially power on, then the BIOS will get called. BIOS will in turn call the bootloader. Bootloader is the one who's going to load the image into the RAM memory, I said. But which part of the RAM memory? It's going to load the memory into the kernel space of the RAM memory. Okay, fine. Once this is compressed image loaded, later what happened, as a part of the further boot process, this will get uncompressed. This will get uncompressed. And finally, what you're going to get, guys, you're going to get a operating system, or the kernel you're going to get. You're going to get the kernel. Kernel or the operating system. Both are one and the same. OS you're going to get. So always in the kernel space, the kernel will always be up and running. In the user space, the user will log in. Suppose in our case, right, in both these machines, I logged in as a Ubuntu user. In this CentOS, I logged in as a CentOS user. Where the user will log in or where the user will be working, the user will be working in a user space. So here what happened, a user by name Ubuntu has logged in here. Here, the user by name CentOS has logged in here. This is how it happens. Now, whenever user is doing any operation, say you would have seen that I executed some few commands here. I went and executed uname-r command, uname-a command, cat space /etc/lsb release. This is the file I'm opening. I'm doing some operations. What exactly is happening here, guys? Here, when a user Ubuntu is doing it, he's trying to execute some commands. Like for example, he's executing a command by name uname-r or else uname-a, or else he is opening a file by name cat of etc/lsb release. Some file is opening it actually like this. He's opening this file. So what a user is doing, he's performing some task. He's executing some commands. So whenever a Ubuntu user is executing all these commands, right? What happened? How these commands will get executed? The commands will be executed by your kernel only. So as soon as you're executing, suppose I go here and I just say uname-r. Enter, hit enter. When you execute this command, the communication is happening from your user to the kernel. Similarly, CentOS might be executing many commands. Whenever he's executing any commands, the communication will happen to the kernel always. So in a user space, the user login and all your application will be running in user space. So in a user space, this is very important concept, guys. We have to understand all these things. So under the user space, user will log in. Any user log in, like for example, Ubuntu user or the CentOS or any, or even like the root user. Any user could be, he will be able to log in. Once he logs in, he will be literally sitting in a user space of the RAM memory. After that, executing any command or application or running any application will happen in user space. In the kernel space, what is happening? In the kernel space, kernel will be up and running. Kernel will be running. Kernel will be always in protected mode. Protected mode. Yeah. And the processes which are running in kernel space has a high priority, Always those processes which are running in the kernel space will always have a high priority. The processes running in user space have lower priority compared to the process running in kernel space. Clear, guys? Is it clear? You have any doubts here till here?
No, sir.
So again, a lot of people are having some notes of why you have to learn all this. You are saying something. I am a DevOps and I do have to read it. It is always better to know all these things. It is always better. It will add a lot of like knowledge to you, and you can able to visualize yourself whenever you're doing anything, right? What exactly happens in the background, so that these concepts will help you to do any kind of a troubleshooting, even when you are working, when you're facing in a real time. All these concepts are required actually, but in some places it is taught in a very clear manner. In some places they don't at all touch all these things, because either they might not be aware or they don't want to touch all these things, because it is very complicated things to explain all these things. And also a lot of questions will be asked by the people, because all are new to this. They might not know or they might not understand, or else sometimes what happened, the students might get bored or they are not willing to learn all these things. So there are many things. That's our reason many of the organizations or institutes or many places, they don't want to touch all these topics, because it is very complicated. Because you might get hundreds of doubts, sir, what is this, what is that, so many things you might ask. But okay, I mean, you will get a doubts, you can ask it. I'm not saying no, because I will get one more level deeper and deeper. I'll do it now. Are you okay till here? Shall I proceed, guys? Okay, no questions, that's fine. Yeah. Now somebody, I think Krishna or somebody, they said something on fork, something system call, right? Who is that person who asked me some system call, this or something, it or fork system call? Now what is happening now? Let me open one more diagram. Let me get into one more detail. Same thing, sir. This is my user space. This is my RAM memory. Again, I'll draw the diagram. RAM memory, the whole RAM memory, or the primary memory, we say. We call the primary memory, RAM memory. And this is primary memory is divided into two spaces. We know very well, which we call it as a user space and kernel space. User space, or some people will call it as a user mode. Some people call it user mode. Even the kernel space, we can even call it as the kernel space or kernel mode. Both are same actually. Now, what happened in the kernel space of your RAM memory? You know that the kernel will be up and running, or the operating system will be up and running. Assume that the whole booting process is completed. Okay, everything is fine. Now the compressed image has been loaded, uncompression happened. Finally, you'll get a complete full-fledged operating system which is running here on machine, and which is running in a machine which is running in your kernel space of the RAM memory. So this is nothing but your kernel or the operating system which is up and running. Correct? Now what happened in the user space, always the user logs in. Always the user. So whenever you log into the machine, guys, the user will always be logged into the user space of the RAM memory. Here, some user by name Ubuntu has logged in. Here, somebody with the name CentOS has logged in. Okay. Or if you have created some more user accounts in the system, assume that I have created a user account by name anything. I can name anything. I can take a name as a Kiran or Krishna or what a Kiran. If there's a user account in this machine, right? Later I will show you how to create user account. But understand that okay, there's a user account by name Kiran and there's a password by name Kiran123. So he has given a Kiran as a username and Kiran123 as a password. He has logged into the machine. As soon as you log into the machine, he'll be ladding into the user space of the RAM memory. He'll be literally sitting in this memory space and he's working. Similarly, like for example, Krishna will log in or whatever, or else Vaibhav or anybody, whoever is a user account is there or not, they will try to log in and work it, right? For example, you have a Priyanka or a Priya, she will log into the machine. She will be sitting in the RAM space, user space of the RAM memory. Fine. Now she's sitting here. What happened, right? As soon as she logs into the system, she will get some kind of a terminal. We call it as a terminal. We'll get a terminal. Terminal, or we call it as a virtual terminal. You can call it as a virtual terminal. We call it as a terminal. Yes. Here, if you see in our case, guys, you could see that this is a terminal. We got it. As soon as I log in, you could see that you landed in this like this, right? This entire thing, you call it as a virtual terminal or just a terminal. So virtual terminal is something like it is a terminal where a user can interact with the system by executing some command or the program. We say it as a terminal. Okay, and each and every terminal has a terminal name. So if I execute a command tty and say enter, so it can see it is showing you some terminal name /dev/pt/1. What is this? We'll see later. Don't worry. Okay, sir. Some terminal name is given like this. Oh, some terminal name is displayed like this when I'm executing this command. Similarly, can I go here and can I execute the tty command here? Let's see whether it executes or not. Yes, it gets executed. It is showing as a /dev/pt/0. Okay, some terminal name it is showing, sir. What is it? We will learn later. Don't worry now. As of now. Okay, some terminal is shown. Okay, it means that this is saying you that you have logged into some virtual terminal. On top of that virtual terminal, working on it. Okay, fine. Good. Now what happened, right? If you go back to your diagram, here, if you go back to a diagram, a user has logged in and he or she has got a terminal now. Through the help of this terminal only, you are executing any command or any application or any program, right? Suppose, for example, you're running an ls application. So assume that Kiran is executing ls application. ls command is executing. He'll execute ls command. He'll execute a date command. He'll execute a pwd command. So many commands he's executing. Fine. So as soon as he's executing this command, he's actually interacting or he's actually communicating with the kernel. Okay, this we already learned earlier that whenever you're executing any command or program, it will communicate with the kernel. But now the question comes, sir, what is this command is all about, sir? You execute ls command. What is this ls command? What is this tty command? What is this uname command? These are all binary compiled programs. These are all binary compiled programs. So all Linux commands are binary compiled programs. All Linux commands. Are binary compiled programs. It means that already the program has been compiled and they're given the name as a ls. Already some program, it has been compiled and they're given the command with the name date. Already some program is compiled and they're given the name as a uname. Already some program is compiled and they're given the name as a tty. So it means that all these commands, tty command, pwd command, ls command, all these are commands. Now, for example, if I execute ls command, it will show me all the files and directories which are there in the present working directory. But since there is no files, it is nothing. It is not displaying anything. Suppose I want to check where this command is coming from. If I execute the command, where is ls, it will show me the path of that command. Okay, this command is coming from the /usr bin. Okay, if I execute a command, file space /usr bin ls, enter. Can you see the /usr bin ls? This command is an ELF64 executable file. It's an x86 interpreted compiled file. So file command will tell you what type of file it is. So ls command is an executable command. So it means that it is an executable file. Is it clear? So it means that whenever a user is executing any command, all those commands are binary compiled program. It means that it has already been compiled. Somebody has written a program for that. It has been compiled. They have given executable to you, and that executable they have kept in this particular path. So whenever I'm executing any command, this command will get executed from that particular path. You have to understand in that way. So when I execute the file command and give the complete path of it of that file, suppose if I say suppose if I execute the date command, it will show me the current time and date. But I want to check where this date command is coming from. If I execute where is date command, it will show me the date is then the same path /usr bin date actually. File space /usr bin date. What is this USR and also I will discuss tomorrow. Don't worry. But try to understand. It is an executable file. ELF means executable and linking format, we say. So now coming back to the diagram. Now what happened, right? Sir, all these commands are executable commands. Yes, sir. Sir, how these commands are written, sir? Through some program. And so there is something like a C program. Like, for example, if you want to broadly understand, there is a program by name ls.c is there. Somebody has written this ls.c program. What they've written, they have written a lot of codes they have written for that ls program. And to code the whole program, guys, what they have did, they have used some APIs. So to code this whole program, I'm just telling you in a very high level, they have used some APIs, application programming interface. Those are some functions which they have used while for coding this ls program. So when they've used this API, so this entire commands, all these commands are nothing but they are invoking their intern implemented by using some APIs. Now, guys, whenever you are executing any command, so Kiran sits here and he executes ls command. He's actually calling internally, he's calling these APIs. You got it? Suppose, for example, a user is calling an ls command. Okay, ls command. ls command intern has a lot of APIs. Actually, it is intern implemented with a lot of APIs. These APIs are actually getting called. If you ask me, these APIs are actually getting called. These APIs further will communicate with your kernel actually. Oh man, did you know all these things, guys? When I'm executing any program or the command, some APIs are getting called because all those commands and everything are nothing but implementation of some APIs. Those APIs are getting called into the kernel level, and that kernel is going to execute your APIs on behalf of this command. This is how it is happening. So it means that all the commands are developed with the help of some APIs. APIs are not, but these are the functions. Like, for example, what are those APIs? There are so many APIs are there, sir. So in Linux, there are more than some 100 APIs, sorry, some 450 APIs are there. Like, for example, Open API, okay, Stat API, fseek API, okay, or else Read API, Write API. Oh my God, these are API. What is this, sir? Don't worry, it is all functions. Don't worry much. All these are functions. So this is a whole ls program have been implemented by using these APIs. Even you can even trace also what are the APIs which are used. How to trace it? See here, I'm executing the ls command. Okay, nothing is executed because there is no files in the address. Suppose I want to trace it. Let me check if there is any strace is there. See, guys, you see, when I'm doing an strace, and giving an ls command, see, strace is numbered. It is actually displaying what are the APIs which are being used to implement this ls command. See, it is intern calling exev, it is intern calling break, it is going to intern calling mmap function, it is open area, see, read system call, mmap API, see, write system call, see, these are all implemented, read system call, access, close. Oh my God, these are all APIs. Okay, super. It means that every command, whatever you're running all these days, it contains a lot of APIs. Okay. So when you are running any command, in turn it is calling an API to execute it. That's all you have to understand. Is it clear, guys? I think some of you have some doubts or something here, or is it too much for you? Don't worry, guys. All these things will be again be clarified to you. I will repeat again all these things in many contexts. These things will come again. I will repeat all these things again, or I will explain in other different ways so that you will be able to understand in a very good manner. But are you able to understand what I'm saying? But again, the same question you might ask, sir, is it really required for DevOps engineer? Not really that much required, but I'm telling in a very high level so that, okay, you are understanding in a very systematical way how exactly the operating system works in a very high level. Later we'll go in other aspects. Yeah. Sir, any other questions, sir, please? Don't worry if you're not able to understand some API, what is it, sir? What is its commands? What is intern calling? Please don't worry. Just listen to me what I'm saying right now. Okay. Any other guys? Any other questions? Narendra?
No, Rajesh, I'm okay.
Good, sir. Sir, did you know about all these things earlier, or this is very new to you?
I'm aware of this.
Okay.
Yeah.
What about Gopal, sir? Gopal? Okay. Yeah, few things new. Yeah, some people have known about this. Yeah. So now, yeah. So, we'll dive into one more level. Then we will stop. We will not continue because it will be too much. So what happened, right? These intern APIs are getting called intern into the kernel. So APIs are actually intern calling the kernel level, or the kernel or the operating system. In the kernel level, there are so many system calls are being implemented. Oh man, what is this, sir? You're saying something now, new thing, system calls. So system calls are getting, so all system calls are there in your kernel space. So whenever you're calling any API, this API in turn will call some kind of a system call which is there in the kernel space. That's what you have to understand. Oh, it means that, sir, Rajesh, is it something like the whole kernel is nothing but the entire kernel is nothing but it is implementation of all the system calls? Yes, sir, it is nothing but the whole system call. But you said like the kernel is having a 5 subsystems like network management, process management, file management. Yes, those are all the models, but those models are internal. It is implemented via with the help of a system call. Oh, it means that at the end, some kind of a system call routine is getting called. Oh, is it correct? Yes, sir. That's how. So it means that entire kernel is implementation of system calls. So then what is the system developer or system level programmer or engineer, what you said, whether they'll be implementing any new system call or whether they'll be working on a system call or whether they will try to understand the system call, how it works. Yes, their main goal or their main understanding that how the system call works in the kernel space. That is the main intention for them to understand in a deeper way how exactly this kernel works. So once they're understanding the system call execution or working flow, they are in turn understanding about the kernel itself. Okay, it means that all this embedded engineer, the system level program, whatever saying, sir, they have to hit this system call. They have to understand system call. Yes, they have to understand system call. What about the application level, sir? Application programmer, what and all they have to understand? They have to only understand the APIs, sir. You go to the C++, you go to the C language, you go to the Java language, any language, they'll be learning about the APIs, how to use that API in their program. Oh, okay, that's all. So API comes in a user space, system calls comes in a kernel space. So somebody is asking, whenever any new process is getting created in the kernel space, there is something known as a fork system call is getting called. Yes, that is right. Fork system is getting called. This is a system call which is implemented in the kernel space. This is the system call which actually creates a process in a user space. Okay. Or it means that the process management. So this fork system call comes under the process management model. Yes, sir, it comes under the process management model. Okay. Like that you have to understand. Clear, guys?
अरे सर पे क्लिक करेंगे तो सर ये तो मेरे अकाउंट से पे हो जाएगा ना, मेरे अकाउंट से कट जाएगा. आप कैशबैक दे रहे हैं या फिर सर ये मुझे कुछ समझ में नहीं आ रहा है. फोन पे कैशबैक ऐसे कब से मिलने लगा?
Who is that guy, man?
तो आपके अकाउंट में पे होगा. हम आपको समझा रहे हैं, आपकी समझ में आ ही नहीं है.
Please mute yourself, guys.
सर पे क्लिक करेंगे तो मेरे अकाउंट से पे होगा ना, आप कह रहे हैं कि मेरे अकाउंट में पे हो जाएगा, मैं बड़ा कंफ्यूज हूँ
Guys,
सर।
this will disturb guys the whole class, please.
It is Faizan, I think you can mute
Faizan,
Rajesh.
please. Yeah, Faizan. Yes, Faizan, please mute. Yeah, thank you. Yeah. Okay, I think in our discussion, right, some people felt very, some people left actually, but that's fine. Okay, so I will not go much more detail in this. Actually, this much is sufficient for you. Okay, there is something user space and kernel space, and we interact with our system with the help of some kind of an APIs, and API in turn will call the system call to do some for doing any kind of an activity. The APIs are in turn getting calling this system call. It means that whenever API is getting called, the kernel will in turn invoke a system call. In Linux, there are many system calls are there. Like, if I'm not wrong, there are around 450 or more than 450 system calls are there. Just for your information, I'm saying system calls in Linux. So understand system call in Linux with the stress command. Yeah, this is the command I executed. System call in details. Yeah. See, these are all the system calls. System calls. Exit system call, fork system call, exit system call, open system call, read system call, right? Device IOCTL system call. Like that, these are all the system calls which are there, sir. Many system calls are there. Okay, like how many system calls in Linux? So if you see it, there would be around, he's saying there would be around, what is it, sir? I think initially they would have told about that. System call table, yeah, all these things, yeah. You'll be having more than 460 system calls, more than that now. Yeah, in some way they would have written, okay, there are more than 460 system calls are there in Linux actually. But if you see the diagram, see, application is in turn communicating with the kernel with the help of some APIs, and this API is in turn calling a system call routines. Like that, you have to understand. See, these are beautiful concepts. You might not really appreciate or understand it. Okay, but I initially at the very initial stage, right, when I was in HP, right, I used to go all these things because guys, please mute, guys. I'm requesting everyone to mute yourself, and please unmute only whenever you have a doubt, please. Thank you. So that's all. Okay, sir, any other doubts until here? Okay, no worries, because today I might have took little more in detail. For some people it might look very difficult. For some people it is okay to understand. Okay, but that's fine. I'm not really worried that if you're not understood, no doubt, no problem for mine. Because I mean, if you're learning or if you're understanding a very basic level also, that's fine for me. My intention is not make you to understand all these things. My intention is that, okay, there is something in a background picture which I'm showing it. If you're not understanding it very properly, no problem. That's fine. Is it clear? So guys, I think we can stop it. It is almost 1:45 right now. We'll stop the session. We will continue tomorrow. Okay. So what I'm trying to do that tomorrow, if in case, if I'm not able to cover whatever I'm expecting to cover, I might ask you or I might request you to join one more session at the evening. But we will see tomorrow how it goes. Because today we spent nearly 45 minutes to 1 hour we spent today in at the initial conversion. We spent that 1 hour, right? We couldn't really start with our topic, right? So it was like 1 hour we are behind now, but that's fine actually. Whatever we are downloading from your drive, I missed the beginning. No, Yasmin, what I was trying to tell that I have my channel Rajesh-Devops, right? In that there are many videos are there on each and every DevOps tools topics. So I used to write the class notes or the running notes in each and every session. So many of you, right, they have asked me, sir, give me that notes, give me that images, whatever you have been drawing in the classes and all, right? That everything is there in the drive actually. Plus I have uploaded a lot of other PDFs, very important materials and PDFs, interview question answers, and everything in the drive actually. So that is just for your reference. Today's class, whatever I'll be downloading, that I'll be uploading, I will share a separate drive today where you'll get all these class notes and the diagrams and everything. You'll get those videos. I'll be uploading the drive. So I'll be uploading today, and within another 2 hours, I'm going to share that drive to you all. Yes, also, Kiran, I will share it. Don't worry. In our main WhatsApp group, right? I am going to give you the drive link so that you can all go and access, or you can download the videos. Today's 2 sessions you can download. Yeah, okay. Fine. Any other questions, sir? Please, you can, I think I can stop the session. Sorry, I can stop the recording.